from this computer. I started just recording from now. Okay, now we're going to take this to another level. I'm way too bad at computers to be doing this. I need someone to help me. Home sweet home. Okay, what I want to do now is take this to another level. And to do that, I'm going to actually make up a problem kind of from scratch. So you're seeing Desmos right now. And I alluded to the fact yesterday that this could be sideways. And so let's play around with that a little bit. I'll start with something easy. So let's see, y equals x equals y squared. That's a sideways parabola. And I don't know, let's throw like a +3 on there. Oh, that's interesting. It slid to the right. You might have expected that to slide up when I said +3. I wonder if you can figure out why that's the case. And let's go down here and throw in another equation. And I'm going to make this y equals experimenting about 1/4 x. That's pretty small. Let's make it go where I want you. Let's make it a half. So it's a little steeper. Now, of course, you have to be careful if you want to make up a problem, because if I say, what's the area between these curves, they don't run into each other. So I got to get that to run into it. So of course, I'm going to slide that unit down a little bit. Let's take it down to, I don't know, how about 6? Sweet. And let's see, can I still screw around with that? Yeah, there we go. Now, you saw me make this up. What's not good about what I just made up? Because I might modify this a little bit. What's not good about what I just made up that's kind of important?
The x's and y's are reversed in the equations?
Yeah, the x's and y's are reversed. But I'm thinking that'll make it harder, which is what I'm going to show you. But what do you notice about where the two graphs run into each other?
They're not on even points.
Yeah, notice it's some weird point. And so again, some of you are future teachers, and I have problems right in front of me that I could use that I've already made up, but I'm purposely making this up on the fly. I'd like those to run into each other at nice places. So how do I do that? Is there some way I could do that, like fix this problem? It's sort of not surprising that they didn't hit each other at a nice spot because I made them up randomly. How could I do that?
Do you set one equation equal to the other and then set it equal to 0?
If I set them equal to each other, a substitute, like for instance, the second one, I could take y equals 1/2 x minus 6. Hey, y is 1/2 x minus 6. Well, then I could put it up in the top equation. I could replace that y up there with 1/2 x minus 6, and I would have a squared equation to solve, and then I would get 2 answers. But I want them to be whole numbers. Do you see what I'm saying? So that'll work. These two graphs clearly hit each other, but they're just not hitting in very nice spots. And you know from using the quadratic formula that a lot of times you get numbers that don't work very good. So let's see. So I'm looking at that top equation. Let's see if that top equation, notice my y value in that upper location is about 4. So I'm thinking, what if y was 4? Let's see, 4 squared is 16 plus 3 is 19. X would have to be 19. And that doesn't come out very even. So I'm going to go back and make this a 2. So now if x is 4, if y is 4, so I want that top point up there. I want it to hit at y is 4. So if y is 4 on the top blue equation, 4 squared is 16 plus 2 is 18. X would have to be 18. Well, then if I go to bottom equation, 18 and y is 4, the question is, what would that 6 have to be? If I plug in y is 4 and x is 18, do you follow where I'm going with this? X is 18 times a half, that'd be 9. If I want this to be 4, that would have to be minus 5.
Right?
So did I get lucky and it even hit on a nice X? Yeah, on what X? Well, 18, we just figured that out. Now, here's where the problem comes in. What about the bottom one? Oh, we got lucky down there. Does that make sense? So much better problem. Would you agree with that? Much nicer. Again, I would, if you don't look at solving that algebraically, finding those 2 points algebraically, if you think I couldn't do that without Desmos, you should go do it. Unless you just think, yeah, that's just super easy. I'm really good at algebra. Go convince yourself you don't need to cheat to get this answer. Okay, so I say, awesome, this is great fun. Let's find the area of that curve, or the area between those two curves. And that's this is an example of a good test question, I think. If I just give you those two equations and say, find the area between these two curves. When you graph them, it's obvious what I mean by that. Look, there's only one place that encloses the shape there. But this is not good, as one of you pointed out earlier, because again, like the problem we just did, your squares are, or your rectangles that we're going to add here are sort of wonky. So let's see if we can play with this in a way that is a little bit mind-bending. So I'm going to take a picture of this, see is that everything I need. Let's move that up a little bit so I can make it bigger. Take a picture, go over into our notes, bring that dude in and draw on it. So I guess I want you to recognize that, let's see, we need to see that point up there. I want you to recognize that this is going to be hard in a vertical sense. Do you understand why this is going to be hard if we do it sort of the traditional way? So that's blue over green, right? No problem. Blue over green. I've got a blue equation, I've got a green equation. Now, what's the problem with the blue equation though?
It goes over.
Whatever's on the left side underneath it.
Yeah, it's the blue equation solved for x. Well, could I solve the blue equation for y? Let's see, x minus 2, take the square root, y equals x minus 2 square root. And so that's okay, right? So I had to rework it a little bit. So as I said before, would you agree that there's kind of a dividing line right here? It's very important to understand what's above what. So we have sort of location number 1 or area number 1, and we have area number 2. We have to do that separately. Do you understand that? It's very important you understand that, because remember, we're going to go 3D with this, so you really got to picture this well.
You don't really understand
that you have to do this in 2 parts. What would you say, Connor?
I was going to say, I kind of had trouble with that last question too. My first instinct was to divide it along the x-axis. So I don't know why we're dividing it up and down.
Well, we're dividing it by up and down because our rectangles are always a width of dx and they're a height of y. Does that make sense?
Yeah.
And in that first space over there, in that first area, my heights are found by going blue minus green, if you will. So I could say blue minus green. Blue is the square root of x minus 2 minus green. What's this person doing wrong? Why is what I wrote there dangerous? True, but dangerous.
Has to be +5.
Parentheses.
Yeah, that it's minus the whole equation, right? So that's going to change that to a +5. So be careful with that. Either write yourself some parentheses or realize the minus applies to everything and just write it as a +5. What are the limits of integration here? Where is that true?
6 to 18.
X is 6 to X is 18. That's exactly right. See, the problem is if you go out of the range 6 to 18, and then you are suddenly over here, does it make sense that you're in a different world there? I guess that's what I want to understand. Do you see how if you went blue to green over here, then what you're going to get is rectangles that go, well, they're either going to go right here. That's blue. Isn't that blue minus green? Or perhaps it would be this blue minus green. And you see that that's not working? Over there, it's not blue minus green. What is it?
Just blue. Or is it blue minus blue?
Yeah, it's just blue. It's like blue minus blue. Do you see what I'm saying? Now that should confuse you a little bit. Anybody know what the graph of y equals? I don't have a pen. Anybody know what the graph of y equals the square root of x minus 2 looks like? It does not look like that blue parabola.
It's just the top half of the blue parabola, right?
Exactly. It's just the top half of the blue parabola.
Well,
What-
because it's square root, don't we have to make it negative, like the plus sign, negative sign thing?
That's exactly
Not
right. This
quite
top
sure what's
half
called.
is y equals the square root of x minus 2. This bottom half down here is y equals negative the square root of x minus 2. So there are still two graphs there. They're two completely separate graphs. Now, from a thinking perspective, would you also agree that you could just find this area? Why would it be cool just to find that area?
Because the bottom half is symmetrical to that area.
Symmetry. Yeah. In other words, I could say blue, I could say the area under the square root of x minus 2 and just go to the x-axis as we've always done, and then just know to double it when I'm finished. So there's some shortcuts, but I'm going to do this sort of the kind of the necessary way, I guess. I'm going to call this y1 and y2. So over here, it's going to be y1 minus y2. dx. And notice, where do these x's go from? Hey, I didn't notice that. I didn't graph that. But notice we got lucky again. It came out nice. It came out at x is 2, looks like right there. So this is from x is 2 to x is 6. Do you agree with that? So from 2 to 6, it's blue over blue. From 6 to 18, it's blue over green. And I'm going to have to add those together when I'm all done. So that would actually be then 6 to 2, y1 is the square root of x minus 2 minus a negative the square root of x minus 2. And of course, there's two of them. One of them minus another negative one is two of them. So I could say, oh, that's two of those. So these integrals now are ready to take, if you will, and I can't simplify them anymore. Are those takeable? Like, can we do that? Are those hard integrals to take? Maybe the square root throws you a little bit of a curveball. Should a little bit, but you should say, oh no, I got the substitution tool. I can do the square root of x minus 2. And just because we have time to think about this, let's do it. Let's see, the integral, this is just kind of a little side note. The integral of the square root of x minus 2 dx. How do I find that? Notice I'm just checking this out. So I'm saying, well, I'm not sure. That's a function inside of a function. So I'm gonna just go slow and be careful and use my skills. And I'm gonna say u will be equal to x minus 2. That's convenient because also that means that du equals dx. In other words, they're interchangeable. That's cool. So then I can say this is now the square root of u du. Do you agree with that? So it's kind of like, hey, that inside is so simple. Doesn't have a squared, doesn't have a 5x, it just has an x. It's so simple that this really wasn't that hard of a problem. Well, you know that the square root of u is really u to the 1/2 power, and you also know that you add 1 to that exponent and then divide by that exponent. And so that gives you, dividing by 3/2 is multiplying by 2/3. That gives you 2/3 u to the 3/2 power. So now substituting back, you could then say the integral of x minus 2 dx is actually equal to 2/3 times x minus 2 to the 3/2 power. So there, when it comes up, if it comes up in my thinking, if it comes up as a part of the problem, I have this kind of little side work that I made. So now I know how to take the integral of square root of x minus 2. Okay, so let's go do it. So back to 1. So this, I'm starting out with the integral of, there it is right there. Cool. Well, I know what that is now. I just worked it out. So that's 2/3 x minus 2 to the 3/2 power. And the integral of negative 1/2 x is negative x squared. No, it's not. What is it? What's the integral of negative 1/2? I got in too much of a hurry.
One half.
Got to raise this power from 1 to 2, divide by 2, not multiply by 2, divide by 2. Yeah?
1/4 x squared.
Fourth. And then that's really a plus 5, so that'd be plus 5x. And the integral is now taken, so evaluate that at 18 and 6. And notice that looks kind of daunting, but it's not going to be. So let's work this out. So if you put 18 in here, notice that actually works out really nice because 18 minus 2 is actually 16. And that 2 right there means square root. So the square root of 16 is 4, and 4 cubed is 64. So I have 2/3 times 64 minus, 18 squared is a big number. 18 squared. I'm just giving you time to think about this. Divided by 4, I get 81, so that's minus 81. And then 18 times 5 is 50, and 40, which is 90. So let's see, what is 2 divided by 3 times 64 minus 81 plus 90? I got 51 and 2/3, or 155/3. Again, it's just cool to plug this in by hand and get it because you can. This is kind of neat. So that's what happened when I plugged 18 in. When I plugged 6 in, 6 minus 2 is 4. The square root of 4 is 2. 2 cubed is 8. 8 times 2/3 is 16/3. So I did all that in my head. 16/3 minus 6 squared is 36, divided by 4 is 9, and then 6 times 5 is 30. So cheating, 16 thirds minus 9 plus 30. It's 26 and a third, which is actually 79 thirds. If I subtract those, I get 76 thirds. Does 3 go into 76 evenly? Who knows that trick? Just little things you should know and pick up as you go through math. Saves you a bunch of time. How do you know if 3 goes into 76? What's the trick for that?
The sum of both digits, so 7 plus 6, and if it equals to 3, which it doesn't, so 3 isn't divisible by it.
Good job. 7 plus 6 is 13. 3 does not go into 13, so 3 won't go into this. Therefore, I'm done. That's just kind of cool. That's faster than using a calculator. So now take stock of where we are. What did we just figure out? All that work, we just found area 1. Like we're not even done yet. And I just did a whole bunch of math. So the chances I didn't make any dumb mistakes right now, like I'm very dubious that I'm going to check this before I'm all finished and make sure I didn't screw this up. But I think I got area 1. Now let's go get area 2, which I was using blue. So let's go back and use blue. And so that area was 2 times the square root of x up there. So area 2 was from 6 to 2. I'm going to write it down here just because it's kind of so far up there this time. So you know the 2 comes along for the ride, so I'm just going to leave it out here. We just figured out a minute ago that the integral of x minus square root of x minus 2 is actually 2 thirds times x minus 2 to the 3/2 power. So there's that integral, and then I evaluate it from 6 to 2. So when I put 6 in, as we did before, 6 in, 6 minus 2 is 4, the square root of 4 is 2, 2 cubed is 8, 8 times 2 is 16 thirds. So I got 16 thirds when I put 6 in, I think. And then when I put 2 in, hey, good news, 2 minus 2 is 0, gone. So it's actually nothing. So I got 32 thirds. Again, very unsure. As a mathematician and as a human, I'm very unsure that I haven't made some kind of a math mistake here. What's my final move here? Again, notice how easy it is to get lost. That's why I'm arguing for, good note taking. Write yourself, write things like this, right? This is area 1, this is area 2, or shade them different colors or whatever. Because you get so focused on just trying to take an integral that you kind of forget what you're doing. So to find this area, I'm adding those 2 together. So that's kind of my final push. And so if I haven't screwed up, notice again, the wisdom of, or the good luck, I guess I might say, of leaving them perfect is I'm adding them in this way, and I get 108 thirds according to Julian's cool trick. Notice 1 plus 8 is 9. 3 is going to go into this number. So therefore, I'm going to bust out my calculator and cheat and say, what's 108 divided by 3? And I get 36. So I think I'm very excited that I think I actually have this area. And again, it's unbelievable to me that comes out as a whole number. I mean, it's just like a curve. And so I think the answer to this is 36. But I very much want to go test that. I'm actually really tempted right now to go to Wolfram Alpha and ask it, like type. I think I will. Maybe this is a waste of time. I don't know, but this is the kind of thing Wolfram Alpha sometimes will do that really surprises me. So I'm just going to try it and see what it says. It'll just be fun to learn. My point is I want to check my work, and I'm just thinking, what's the easiest way I could check my work here? Maybe I go to Desmos. I don't know, but maybe I could type all of this in Desmos. But I'm just going to try Wolfram Alpha and see what it says. This is the one strength that it sometimes has. So original problem. Find the area between x equals y squared. I'm gonna be surprised if it actually does this. X plus 2 and y equals 1/2 x. That's not 1/2, 0.5 x minus 5. That was our problem. And so we say, go get it. Let's see what it does. That's a pretty complicated thing to ask, isn't it? Notice it said, basically, nope, that's too hard. I don't know if it doesn't understand what I'm asking. I don't know if that's just too complex of a question. I'm not really sure. What do you think? Like, what is the, how should I check that? I mean, what's the, would it work in Desmos just to go, I gotta reshare my screen here.
I think Desmos would be the best, but the hardest part for me is kind of knowing what to subtract. So as long as your equation's right, it should be easy. But if your equation's wrong, Desmos will just fact check the wrong thing.
Does it make sense to you that if I rewrite the blue equation like this and I leave the green equation alone and I graph those two and I say, what's the area between those? Do you understand it's going to get that wrong? I'm going to screw up. I'm going to erase what I write here because I'm going to mess up my notes. But remember, the square root is from here to here, right? The square root of x minus 2 is there. And if you say, okay, the area below the blue graph and above the green graph, does it make sense that's going to go straight down and give you this entire area right here? My point is it's not simple to even check this, even if you're cheating. That's kind of why I thought it'd be fun to see if Desmos did it. But I just want to show you a different approach to this. What you can see is by the fact that one graph was not always above the other graph, that made this problem double. You understand that? We had to do two separate problems to get this. And so is there another way? Yes, is the answer. There is a better way. Let's try this now. Let's expand your brains. A better way. Is there any reason that we could not turn our rectangles sideways? Why do the rectangles always have to be vertical? Why can't the rectangles be sideways?
Well, for the rectangles being
Say it
vertical,
again.
for the rectangles being vertical, what we're doing is we're using delta x as the width, and then we're using the function of x as the height. So we could do the same thing and swap them and use the function of x as the width, or the delta function of x as the width, and then x as the height, or delta x as the height, I guess. But we'd have to solve for the other variable first, right?
Yeah, if we turn these sideways, isn't the height of our rectangle, now a little bit of y. It's a tiny y. I mean, isn't that a y? That's along the y-axis, right? That's a teeny bit of y, not a teeny bit of x. It's a teeny bit of y. And remember, the d implies teeny, actually non-existent. It's not just small y, it's non-existent small y. And then aren't our x's, I mean, isn't the kind of the height of the rectangle? Again, it's, what do you call width? What do you call height? I mean, I always think of height as the tall one. So in this case, I'm just saying dy is the width and x is the height. So if I pick sort of a given location, let's just say we're here at 1, we're here at y equals 1. Does it make sense? That's kind of an x coordinate. I'll call it x1 to get to that point. And then it'd be kind of the other x to get to that point. And so if we really wanted the size of the rectangle, it's not, in this case, just like in the other case, it's not really sort of just x. It's actually, well, if I'm calling this equation right here x2 and this equation x1 now, then this is really x2 minus x1. Do you agree with that? Like, that's how tall that is? I mean, aren't those two x coordinates? That's how you get over there. You see, this is the same thing. It's just sideways.
So really, aren't neither of them better? They're just equally the same because you still have to resolve the equations for one of the variables and solve it just in terms of one sideways and one vertical.
Yeah. And the only thing I would say is, if I had went back in this problem and thrown a y in there, see how it says x squared plus y squared plus 2y? Does it make sense how hard that would have been to solve for y? Sometimes it's flat impossible to solve for y, like you can't even do it. So we'll talk about that a little bit. But my point here is this is actually easier. This is a really important statement here. The green graph. The green graph is always above. When I say above, I put it in quotes. The blue graph. If I was doing this live, I would turn my paper, but if I turn it now, nothing happens. You can't even tell I'm turning it. But if I turn this direction, let's see, is that going to work? I can't even read it because it's upside down. Do you understand what I mean when I say the green graph is above? Do you see how if I turn it sideways, there's not two problems? There's not two separate areas here. The green graph is always further away from the y-axis than the blue one is. So I don't have to do two separate problems here. So this particular problem, I made it up so it could be done both ways, but many problems can't. Generally speaking, when you see x equals like you saw here, that's just kind of a clue. Hey, do it sideways. So let's see if we can set this up. So what I need then is I need the integral of green minus blue. And, wow, I said that kind of, no, that's right, we're good. And I really need that green graph solved for x just like the y one is. Do you understand that? Notice, as I said over here, this is really x2 minus x1. In other words, I need those solved. Notice this dy right here. the dy means I have to work with y. Do you understand that? It's got to be y values now. So if I resolve the green graph for x, that would be y plus 5 equals 1/2 x. I would multiply both sides by 2, so I'd have 2y plus 10 equals x. So now I have x equals gobbledygook and x equals gobbledygook. So what I'm really saying here is, well, as I said before, my heights are x2 minus x1. That's the height of my rectangle. But then there's a dy for my width. Do you see how those compete against each other? Like if one is x, the other is y. But we can't do that. We need them all to be the same letters, right? And so you got two choices. You could change dy to dx somehow, or you could change those x's to y's. And that's why I need these solved for y. So now I can come back and say, well, what is x in terms of y? Well, there it is. It's 2y plus 10. And what is the blue graph solved for x? Well, it's already solved for x. So y squared plus 2. I'm going to be careful and put parentheses there. Does it make sense? That's fine now because it's all y's. Everything is y. It's exactly the same thing we did before. It's just you were an autopilot. Always, you just automatically subtracted the equations, the x equations. I'm going to redraw our little rectangle down here. dy x2 minus x1. And remember what this symbol means. What does that symbol say to do with these rectangles? It says sum. Add them all up. And by the way, dy is 0. Add up infinitely many rectangles. Now, what do I do here?
Hang on, Doug.
Here.
I'm really confused. You lost me. What did you functionally do to the equation to make it x? I'm just not sure what you did.
Yeah, well, we got some time. I guess we got 5 minutes of time. Because it makes more sense to turn our rectangles sideways in this case, because the green graph is always above the blue graph, then all of a sudden, instead of dx and y, now all of a sudden I have dy and x. And yeah, well, I'll finish this, but we can stay after class and stare at it. Since everything is y, does it make sense I have to now think in terms of y? Like what y values do these two graphs live between? Do you see that they live between y's of 4 and -2? Now I'm using y. Not 18 and 6, but 4 and -2. Everything is y. Now when you stare at that integral, do you think, oh, that's easy? I hope you do. It's easier than the last one. Way easier. So just to clean it up a little bit before I answer it, since there's a 10 and a 2 there, I think I'll just rewrite it. So we got 2y plus 10 minus 2, so that's actually plus 8, and then minus y squared. Isn't that a really easy integral to take? So let's see, what is that then? The integral of 2y would be y squared. The integral of 8 would be 8y. The integral of y squared, add 1 to that y. So now it's cubed, and then divide by 3. Evaluate this at 4 and evaluate this at 2. What am I hoping the answer to this is?
$36.
36. Again, I'm not sure it is because I just did a lot of math. I mean, if I did everything right, it's 36 because there's two ways to do this. The way I just did this is much easier. So I'm just going to go type all the names. I don't trust myself. 4 squared plus 8 times 4 minus 4 to the third divided by 3. When I do that, I get 26. I'm going to go fast here. 26 and 2/3. When I go back and do this with -2, insert 2. I think I got -9 1/3. Is that good news?
Yep, nailed it.
It's extremely good news because that adds up to 36. So as a human being, I'm breathing a sigh of relief right now because that means I didn't make any mistakes in everything I did earlier, which is in my case luck. But secondly, because you guys pointed out mistakes, like remember Eve saw that I didn't even write down the -8 right. So that would have caused me some problems. What's your thoughts on that? I mean,
I am just made of questions.
this is very confusing. Let me set up one more really quickly for you. We won't solve it, but I'll set it up just so you can kind of see it in action. So this one is canned, and so I'm hoping that means it works good. So here's one equation. It is x equals y squared, but not so simple, -3y plus 12. Second equation, x equals -2y squared minus 6y plus 30. All I would hope for is that when you stare at that, you would say, hey, 2 sideways parabolas. And because one is positive y squared, the other is -2, that means one is going left and one is going right. Like that'd be great if you remember that from Math 111. Let's quickly go over to Desmos and graph those because this feels daunting without a graph, doesn't it? Like I need to visualize this stuff. So I really want to see these things. And Desmos, unlike your graphing calculator, my friends, has no trouble with these letters being backwards. These are, mathematicians would say, not functions. Y is not a function of x. And so your graphing calculator can't do this, but Desmos can. So there's my first sideways parabola. It's a positive y squared, so it points right. Just like a positive x squared points up, positive y points right. Maybe you remember that. Then the second one is x equals -2 y squared minus 6y plus 30. I found myself being much happier because now I can actually see the area that we're talking about. Oh yeah, okay. This makes sense now. I see what you're asking me. I didn't get that before. I didn't even understand what you meant. I didn't even know what these look like. And now I'm going to go in here and say, oops, I guess this wasn't so nice, was it? Did I type everything right? The answer is no, that was a 12. Thought I took the trouble to make these up nice. Y squared minus 3y plus 12, -2y squared minus 6y. Wow, I'm like an idiot. There we go, baby. Plus 30, okay. So yeah, baby. Right on. Like that's a test question. You see what I'm saying? Like it came out nice. Do you see that this is important to do sideways? It's going to save us a lot of time. The black graph is always above or further to the right than the purple graph. Not only that, if you wanted to do this the normal way, then you're going to have to resolve these equations for x and y, or solve them for y. Good luck with that. It can be done, but it's quadratic formula. It's very messy. You have to do this question sideways. That's what I'm saying. Let's see if we can set it up just as a solving the integral is not the hard part. It's just visualizing it and setting it up. And please interrupt with questions while I'm setting this up, because what I'm trying to teach you is how to conceptually understand what we're doing. And it's a lot to ask because we're going sideways now. So I'm going to purposely relabel this graph x1 and relabel this graph x2 for no good reason. And I'm going to draw my rectangles in here. Here they are. And so since all the way out to here, that's the black graph, which is x2. That's the x coordinate of that point right there. And then to get to this coordinate right here, that's the purple graph, that's x1. So that means this is x2 minus x1. That's how wide that is. And then this height is dy.
So this method wouldn't have worked or mattered with the triangle question at the very beginning, huh?
Yeah, like the triangle could be really done either way. But this question cannot be done either way, like has to be done sideways.
Okay, I see that now.
So my integral then is going to look like this. It's going to be the width, let's see, times the height. And this time I'm just going to lay the triangle sideways. I mean, normally you say the width is this way and the height is this way. So it's really width times height. I mean, you add those all up. It's those rectangles. That's what we're doing. Well, what is our width? Our width is x2 minus x1. Our height, however, is dy. That's not good because one is x and one is y. So I've got to switch that out. Well, thank God our equations up here tell us how to switch out x2. X2 does not have to be x, it can be y. All I have to do is switch out what it is. Like, look, there's x2 right there. I'll replace x2 with what it is, negative 2y squared minus 6y plus 30. There's x2 replaced with y's. And then minus x1, which again, I'm going to be careful and put into parentheses. That's y2, y squared minus 3y plus 12. There's x1. And all of that, in a sense, you don't have, I usually don't bother to draw these in, but that's essentially that's the width of our rectangles. And the important thing there is it's all y's because we're stuck with this dy out here, which is actually our height. So what's missing? I'm only one thing missing and I'm ready to rip. What is it?
The limitations?
Yep. Again, notice we're working with y's, and so I need these y values. Well, these rectangles exist between a y of -3 and a y of 2. So if I put -3 and 2 in there, ready to rip. Notice the integral itself is easy. That's not a hard integral. -2y squared minus y squared would be -3y squared. -6y plus 3y would be -3y. And 3 minus 12 would be -9. If you want to notice, hey, look, those all have a 3 in them. I think I'll pull a 3 out front of the integral. Go ahead. That's fine. You can do that if you want to. -6 plus 3. Not a hard integral to take. So just power rule. Y cubed divided by 3. Hey, those cancel. So that'd be just -y cubed. Y squared divided by 2. So that'd be 3 divided by 2. And then -9 grows a y. Now I evaluate that at 2 and -3. And then I think I have the answer to this question. See if I have that left over from some previous notes. What I'm worried about here is not the integral taking, it's the conceptualization of the problem. How you doing? Like, as Connor said earlier, I'm filled with questions. How are you conceptualizing this okay? Is your brain in pain?
Wouldn't that -9 be different because it was plus 30 instead of plus 3?
Did I write the problem down wrong? Plus 30, not plus 3. 30 minus 12 is 18. Thank you for catching my stupidity.
I think conceptually I'm doing a lot better, but I was a little curious when you messed up the equations the first time, it had kind of crossed over the y axis in multiple points. Does that matter? Or because it should just minus out like the other side, right?
Yeah, just like before, like if the yesterday, if the y is negative, then when you subtract the negative, it ends up adding it anyway. So yeah, you can just sort of mindlessly subtract the two equations. But the key is which one is above. You got to be careful not to subtract these backwards. Does that concept make sense? If you subtract backwards, then again, you're not going to get it wrong. You're just going to get a negative area. If you get a negative area, you know you got it backwards because an area cannot be negative, right? So the cool thing is you actually know that you got it right.
And by above, you mean like which one's further from the y-axis?
Exactly. By above, I mean which one's actually further from the y-axis.
Okay, I get that.
So that's why it's really important to draw this picture and why it's really important to see kind of the x2 out here, you know, that goes way further. That's how far away that spot is. And then x1 only goes to right here. And so, oh yeah, I get that by subtracting those two. And if I get it backwards, I'm going to get a negative number. So cool. I'll just write down the right answer and we'll say we're done. As far as right now, by the way, just so you know, in the interest of time, I'm using my graphing calculator just to cheat and give me that integral right there. But how am I doing that on my graphing calculator? I can't do that, right? Because it's got y's in it.
Can you do?
Can't you just use X?
Yeah, I just switched it out with x. I just typed 3x squared, 3x, and 18. And I got 62.5, which is kind of cool. That's a terminating decimal. So I can actually say again, equal. That's really cool that you can say it's equal. It's perfect. Crazy that it's curved and it's perfect. But again, you know, did I type it all in right? I had to write everything down right. There's just all kinds of dumb mistakes you can make. So I think that's right. But obviously, you know, there's a lot going on. I mean, one question on a test like this is 15 minutes, right? So what's the chances you're not going to make a mistake? So practice writing your workout really clearly, because, you know, if I was, as I often say, if I was grading what I just did earlier and there was a 3 sitting right here, I would be, this is what I would do on your test. Have you seen me do that already? Dude. But, you know, you watched me do that and I didn't do that for your benefit. Like there's just a lot going on, man. It's hard to concentrate, hard to keep it all straight. If I can see that the only reason you got this problem wrong is just because of something stupid like that, I might not take off any points. And I especially won't take off any points if down here you say, I got 62.5, but the answer is 97 and I don't know what I did wrong. Now, not only is your answer wrong, but you even know it is. And then when I go look at your mistake, I realize your mistake is something irrelevant. It's just silly, you know, it's an accident. It's not that important. 30 minutes up. That was 18. I had already subtracted at that point. All right, get yourself out of here and we will, let's see, what is today? Today would be Thursday. So we'll pick it up on Monday. We are going to be talking on Monday about volume. You need to practice this. I guess I just want to warn you, we're done talking about area. You can now find the area of anything. But you might need more practice than what I'm giving you on My Open Math. Like you have problems in your book that are odd numbered, the answers of which are in the back. So just pick them and solve them. But the important thing is not, can you get the question right? But as I said the other day, what we're going to do is we're going to take this shape right here on Monday, and we're going to take that shape right there, and then we're going to spin it around the y-axis and say, what's the volume of that? If you can't conceptualize this, and we're going to spend a couple of days on that, but you've got to conceptualize this. It's very hard to go 3D. You got to be able to draw a reasonable picture. You got to picture what that shape is going to look like. We're not going to be adding up rectangles now. We're going to be adding up cylinders. So there's a jump in dimension coming on Monday. You need to be good at this by Monday. Otherwise, it's going to feel real confusing. So if you're not inclined to spend plenty of time, make this one of your exceptions, because this will be where you begin to get lost in Calc 2. And it's easy to solve if you just draw lots of pictures. And thank God you guys live in an era where Desmos exists, where you can actually draw these pictures. Notice I was able to, like, I couldn't graph that when I was in school. There's no graph for that. You can't graph that. It's too confusing. It's too weird. It all had to be done just like mentally. You couldn't see anything. Take your time, draw pictures, make sure that you're not writing one thing down that doesn't make sense to you. Make sure that what I wrote here, hey, all we're doing is adding up rectangles, width times height. This time our width is X's and our height is Y's, and make sure you're conceptualizing. I'm still just adding rectangles. All right, stay after. See you on Monday.
Doug, with how often we run over, you should really just say this is an hour and a half class instead of an hour and 20 minutes.
You're not wrong. You're not wrong.
See you Monday.
See you Monday.
Okay, I have a question that relates for me and my group.
Yeah, go ahead.
So we're trying to find C, and I'm not sure if we should be like constantly pondering on how to find C.
No, you should be cheating.
Okay.
So on the bottom of my the main purpose of this project is that you would conceptualize what an integral can do. What we did today is the mechanics of finding an area that,
Okay.
for the most part, like we're just finding a weird area. It's very cool that you can do it. Don't get me wrong. But what I'm giving you is a problem where the mechanics of taking the integral are super hard, but actually finding the answer to the integral, really practical, really interesting, really worth doing. What am I doing in there? I'm not supposed to be in BC Calc. So
Okay.
you should be cheating to get the answer to the area. I'm just interested, can you conceptualize it? That's what I'm interested in. So with respect to your group, did you successfully figure out what this area should be here for you? How many pounds is yours?
Yes, we did 151 pound person,
Got it.
which leaves a total of 195.
Got it. So here's the question. I just picked a number randomly here. I just picked 280 for my weight, and that's kayaker
Okay.
plus boat. And I made a little formula for myself to kind of save me some time here that I kind of don't want you to see. What do you do to that number to figure out what this green area is? Because that's the amazing thing. You know how much weight you have, and thanks to Archimedes, then we know how much that's exactly how much water is going to be pushed out by that boat. 195 pounds.
Okay.
What did you do to 195 to come up with this area? Did you figure that out?
Yeah, so I just, well, the worksheet came with a bunch of
Yep.
ways to change the units. I just kept filling it. So from like pounds, I changed it again and so on until I got to inches. And then I just divided the length A4
What did you
to
get?
get a two-dimensional.
So what did you get for that?
64.226.
Okay, good. You got that right.
For the area,
Yep.
it was 64.2.
That's right. So, and I made this particular Desmos so that I can grade yours. So I know yours is right because I just checked it against mine. Now, all you have to do is say, okay, well, here's my equation up here. That's everybody's equation. Why is that everybody's equation? Well, because the 13 represents how wide the kayak is and the 6.5 represents how tall it is. The only question C is how deeply does it sink in the water? So the point is with 195 pounds in it, it's going to sink in such a way that that area right there, as you said, has got to be 64, right? All I'm saying is just go guess. The integral that you take here is too hard right now. So use Desmos, play
Okay.
with it. In the real world,
Sounds
you
good.
do calculus to do calculus anyway. So obviously, do you see how mine's labeled? If you will, I guessed 4.7. And when I guessed 4.7, notice the curve hit at negative 8.98 and 8.98. And so then I have to put those numbers in to the integral, and then I ask it what it is, and it says 22. Crap, you should say. I needed that to be 64. So that's way too small. That's not sinking as deep as it's going to sink. And so then you go back and say, all right, well, maybe I'll make C 3.5. Try it again.
Well, yeah, that's what I did. So I actually know the answer, I guess. Do I need to do anything else other than doing that?
No, what'd you get?
I got 2.716111, whatever all those other decimals.
2.716. Notice that's correct because you see what the area is right there? It is what you said it should be.
Yeah.
So now,
Sweet.
yeah, as a math student, you should be like, what? We're guessing and checking for a math assignment. But do you understand, like, this is what integrals do? You just designed a boat. You know exactly how much it's going to sink in the water now. In a sense, you know what this distance is. And that's gigantic in terms of engineering design. You don't get this without an integral. That's really cool. It's really powerful. Now, if you want to try to get this without cheating, wimping out, using Desmos and so forth, great. Stay in class for the rest of this class, and it's going to take a while to be good enough to actually answer this with skill, because not all integrals are simple. The integrals we did today, the integral of y squared, that's super easy. The integral of the square root of 169 minus x squared, not simple.
Okay. Thank you. And do you also want the volume of how much we go into the water?
No, all I really need
And
is
just multiply it back by 84.
all I really need is the weight that you chose, and from that I can calculate the 64 that you got and make sure you got that right. And then you're going to tell me what C is, and then I can kind of check it against my little cheat Desmos that I made here that allows me to grade your stuff really fast.
Perfect. Thank you.
Yeah. Keep going. Who else has questions?
I had a question on 6.1 homework.
Mhm.
The last part on question 2. I wasn't sure how to get to that part or how to solve for that one.
Got it. So this is a bit of a trick question. Do you notice B and C look like the same exact question?
Yeah, that's what I thought. I was confused on that.
Yeah. So it has to do with this. My hand is at the bottom of the screen, right? Is that what you're seeing?
Yeah.
So let's say I traveled, up to my mouth, and then I traveled down here, and then I traveled up to my shoulder, and then I traveled up to here. Well, how high did I just travel? Well, in one sense, you traveled a long ways. You went a mile and 6 miles and 4 miles and 2 miles and 1 mile. You went 19 miles. But in another sense, you just went from here to here. Does that make sense? I mean, maybe you went all over the place. So one of those questions is saying, what's the total distance you actually walked? The other one is like, what did you actually accomplish? You see what I'm saying?
Oh, okay.
And the bottom one is the one that says the total distance. So if you just do calculus and you say, oh, 0 to 3, I'll evaluate it at 0 and evaluate it at 3, all you're going to get is you started at mile marker 6 and you went to mile marker 12, and so you traveled 6 miles.
Mm-hmm.
But in reality, you might have went down and up and down and up, and so you got to look at the graph and to get C right. And
Okay.
break it into smaller chunks, because some of that time you were going left and some of that time you were going right, or some of that time you're going up and some of that time you're going down. And so think about that. That's a good
Okay.
I just had a quick question about that one. So for the first part, we're taking the integral of that, so it would be like -9 cosine
Yep,
14 minus 14.
that's right.
Okay, because that's what I did, and it said that my answer was wrong. And I think I tried it twice, and it's like the same format for the answer, but it didn't like any of the ones that I put in there.
Okay, so this is a little tricky because remember what initial velocity means. The initial velocity means what time is it?
0.
Times 0. Now this is a weird problem because when you put 0 in for t, that cosine is not 0. So you look at that. If I put 0 in my equation I just typed, which is what you thought it was, which is, by the way, also what I thought it was for a second. But if you put 0 in for t, what is -9 times the cosine of 0?
-9.
That's exactly right. So therefore, you can't just stick -14 on the end quite so simply. So you want, when you put 0 in, to be -14. Therefore, if that part of it's already 9, then this would only have to be 5. Does that make sense?
Oh, I see. Yeah, that makes sense. So that when you have 0, then you're left with -9, and -9 minus -5 is your initial velocity.
Yeah, which is supposed to be -14. So that's tricky because usually when you put 0 in, it's just the number is -14. But let's check and see if I got it right. Yeah, baby.
Thank you. See you Monday.
See you Monday. So before you go, Cheyenne, you probably don't want to talk about this, and that's fine. But I after you and I got off the phone or whatever about that extra credit problem, there is an algebra, like a mess, like because you just sort of did that quickly and we're trying to make sense of it, like you got something wrong in there conceptually. But your process, like everything you did was awesome, but because of just not being careful substituting, I think you ended up with something on the top that should have been on the bottom, or something like that. It was, so if you want to talk about that, we certainly can.
Yeah, and I went through it again, and I ended up with basically the same answer, except it's a little cleaner. So I am curious to know what went wrong.
Okay. So did you start out and say, okay, great, let x be 13 sine of u? Yes?
Yeah.
So I think this is where you went wrong. Do you see how this is weird? Because usually you're saying let u be equal and then x is complicated. Whereas in this problem, because you let x be that, then dx equals 13 cosine of du. Well, that is dx. So you're not dividing cosine away to the other side. That is dx that you're replacing with this dx up here. It's already solved for dx. Does that make sense?
Okay, so my dx instead of being du divided by negative sine of u, it's just the 13 cosine.
Exactly. It's already solved for dx. Like you're used to dividing it away and so forth. But again, that's a kind of an algebra mistake in the sense that you're just not being careful of what you're trying to get rid of. Now, if you do that, just as a precursor, you're going to get cosine squared. Now you have the integral of cosine squared, not cosine divided by sine, but cosine squared. And that's not good. Except for, I'll give you a hint, there's an identity from Math 112 that tells you how to replace cosine squared with something that's not squared. It was something like 1 minus the cosine of 2 theta, or divided by 2 or something like that. So
Okay.
cosine squared is not good. Like that sounds pretty simple, but it's not just sine squared or something like that. So there is one more substitution that has to be done. But the cool thing is the second substitution is not changing the letter. You're not changing from X to U. You're just changing the way that statement looks, if that makes sense.
Okay, so I guess later I'll go through that with this new information and see
Yeah, to see
what
where.
happens.
Good question.
Hey, would it be okay if I shared my Desmos graph for the project? You can look at it and tell me if it looks right.
It would be outstanding if you did so.
Awesome.
You are now empowered to do so.
Okay.
So let me ask you guys a question while you're sharing that. Like the first part of class today, I just was teaching from the iPad only. What was that different to you guys? I don't have a total sense of what you guys see. Was that very much worse, or you didn't really notice?
I think it was worse. I don't think it was very much worse.
Okay.
I think it was fine. Yeah.
Okay.
So anyways, I just guessed and checked to found C. I created an equation for A, so I didn't even have to mess with it.
Good for you.
Here's the area calculated. So here's my weight.
Nice job.
And then just to be sure that I had it right. And I wasn't sure about highlighting this blue part, highlighting that if I even had that correct, but.
Good job. Yeah, you don't have to do that to answer it. I'm just opening mine up right now to double check mine against yours. I got the same answer.
Okay.
So 180 plus 44, so your total weight is really 224.
Right.
And so you got an area of 73. That's what I got. And then you thought the C was 2.317. How'd you get that so accurate? Did you just play with that forever? Like it's out to like.
I played with it for about 10 minutes.
You just type A and you wanted it bang on the money.
Yeah, I was trying to get it exact, using algebra, and I couldn't figure it out, and I gave up. So it's like, well, I'll at least try and get it accurate by guessing.
Yeah. Yep. You nailed it.
Okay. Perfect. How do you want us to present this project? Like, do you want us to put it in a Word document with how we got there, or what?
No, this can be pretty ugly. Like if you sent me that with,
Okay.
with, just a little bit of an email note, our design weight was 224 pounds. And, your Desmos is really clear. Like I can see your conversion there is really cool. I like the fact that you can just kind of type that in, but you can appreciate if somebody was really designing boats for a living, or maybe you're custom designing a kayak and you knew how deep it should sink to be a good balance between stability and speed. It'd be really cool if you didn't have to sit here guessing, that somebody could just kind of call and say, hey, I weigh 230 pounds. And, then you could just kind of throw 230 into your little Desmos here. And then boom, out pops the answer that they need.
Right.
So then you can say, well, no, you need this size boat because you don't want to sink that deep. And it's like sitting here guessing and checking, it's kind of lame. And so is there some way to do
Yeah,
that?
I agree. I thought it was pretty lame, but I figured if I was going to do it, I'm going to do it pretty accurately. So.
I like it. Good for you. And incidentally, that's what Cheyenne and I were just talking about, because what you're really doing is taking the integral of your f of x equation there, 6.5 times 1 minus x squared over 169. And then what you now know is the integral of that needs to be equal to 73.77. Does that make sense?
Oh, okay.
And so it's different. Like everything we've done up to this point is always take the integral of this equation and see what the area is. Whereas this is, hey, here's this equation, but when I take its integral, I need to get 73.77. So the unknown is the C. And unfortunately, the C comes along with unknown limits of integration. So again, I compliment you for replacing that. So
Okay, so the integral of f of x needs to be equal to the area, right?
exactly.
Okay.
And then your limits of integration are even an equation, like your
Right.
if you will, is the square root of 169 minus 4c squared. And so somehow you've got to solve that calculus algebra statement. And so, yeah, there's a way to do this by hand. Absolutely. But it's painful. So
Would the equation I already used for my limits of integration be helpful? I think I just solved for x here.
very much, because instead of, you're used to putting like, what's the area under this curve from like x is 2 to x is -5 or something. Well, you're going to say, what's the area under that curve from the square root of 169 minus 4c squared. Now, because of symmetry, you could say from the square root of 169 minus 4c squared to 0, and then just double it.
Right.
So to set that up and try to solve it, that's the point.
Gotcha. Okay. Thank you so much. I appreciate it.
Good thinking.
All right, I think I got I was gonna ask a question, but I think you just answered it right there. So thank you. See you Monday.
See you Monday.
I was gonna ask about the intercepts there, just to make sure those intercepts, is that how far in the water the kayak is? I think the kayak is 13 inches tall. And so if you have an x intercept of 12, then that means your kayak is like an inch above the water?
No, it's really, I mean, you're close. Let me share my screen again. You're mixing up the width and the height. In other words, the radius is 13. And so if this is at 12, that means your kayak sticks an inch past where it hits the water. You see what I'm saying?
Right. So that
this distance is how deep it sinks in the water, and that's actually the important one. So see how in the example I have, it's 4.182. That's the actual really interesting one. Basically, you're saying, and in the real world, you wouldn't be saying what is C, you'd be saying how deep does this thing sink in the water? And the answer is 4.182 inches. That's amazing to know that before you load it up. I mean, can you appreciate you've got to design a cargo ship to hold a certain amount of weight. Again, let's oversimplify it, like in this example, and say it holds, what did I put here? It holds 224 pounds. And then to know that's going to sink, exactly how much that's going to sink in the water, that's pretty awesome. And you can't not know that, because ships cost millions, billions of dollars to build. And again, the interplay is if it doesn't sink deep enough, it'll tip over and then you lose everything. If it sinks too deeply, then it's really stable, but now it's plowing so much through the water that it has a ton of friction on it. It can't go very fast. So ship design is a combination of speed and stability, and you got to get that right in order for it to work correctly. And also you got to think about oceans, you know, like if it gets kicked in an ocean storm too far, it will tip over even if it is designed well. And we have a lot of stories of that kind of an incident happening as well. So, you know, or maybe, you know, it sinks really deep and it has good stability, but the top of the boat is only a foot above the water. So waves are like going inside the boat. Like we can't have that either, right? So.
Okay, yeah, because I was just finishing up the project and I wrote like a small paragraph in Word about, you know, what the graph is showing. And I wrote that because the x-intercept was like 12.3, then that means that the kayak, which is 13 inches tall, is only an inch above the water, but the kayak is not 13 inches tall.
Well, it is from top to bottom. but you know, this white part here is again, we're visualizing this as upside down. This white part is above the water and the green part is below the water. And that has nothing to do with the x-intercept. You see, it's more like the y-intercept that's determining those. Does that make sense?
Yeah. So I'll change that.
Yeah. So
Okay. Thank you.
yeah, so say something about, since C is really the distance right here from the center of this up to here, that's C. If you take, since the radius of this kayak is 6.5, not 13, 13 is the whole distance, but the radius is 13. If you take 13 minus C, then that gives you the part that's underwater, which is actually the interesting thing. Does that make sense? That's what you want to say if you want to say something cool.
Okay. Yeah, I'll do that then. All right. Have a good weekend.
You too. Bye-bye.